Welcome to section 6.3, and this is called sigma notation. And basically what you need to know is what sigma is, and sigma is a Greek letter, and that's what it looks like. And when you see this Greek letter, you need to start thinking of something called summation, which if you see that word sum really just means adding. And it's really sort of a handy shorthand way to write down things that we want to add. So let's do an example, and I think that might help you understand what we're doing here. So, example 1. Summation from n equals 1 to 4 of 2n plus 1. And what you are going to see in a summation problem like this is different pieces. And basically, this n here corresponds to the n in the equation. It could be an x, it could be an I. It doesn't have to be any particular variable, but that's going to be the thing that's going to tell you what you're going to sum. This number here tells you where to start, and this number tells you where to end. And of course, we need some kind of equation. Let's call it a formula, actually. So we'll call this a formula. Okay. So to do this by hand, I like to kind of think of it as firing up a summation machine. And this machine, the way it works is it starts at 1. So I'm going to put a 1 in for n. So 2 times 1 plus 1. And since it's summation, I'm going to now add the next term it spits out. So now I'm going to put a 2. And by the way, we're using integers here. So 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1. So now the machine shuts down because its endpoint is a 4. And now I just have to do a little arithmetic. So 2 times 1 is 2 plus 1 is 3 plus 2 times 2 is 4 plus 1 is 5 plus 2 times 3 is 6 plus 1 is 7 plus 2 times 4 is 8 plus 1 is 9. And when we add those numbers up, we arrive at the number 24. So one other vocabulary word, and that is, before I actually go through the process of adding those numbers up, this is what we call a series. And basically a series is the indicated sum of the terms of a sequence. So from before then, the sequence is this part, the 3, 5, 7, 9. But the minute we put these addition signs in between, then we have what we call a series. Now that one wasn't too hard to do just using our brains, but our calculator can also help us. So I'm going to go ahead and bring up my calculator and show you how to get your calc to help get the job done here. I'm going to first hit my stat button, and hopefully something's going to come up, but it's not right now because I'm having some kind of a problem. Not sure what it is. Try again. Well, I'm going to go ahead and close this down and bring it back up again. I'm going through some technical problems here this lesson. It's the 4th time I'm doing it in my classroom by myself, but that's okay. Let's try it again. I'm going to hit the stat button. Now it's working. I'm going to hit enter. And I am going to actually clear this list because I'm going to use it here in a minute. So I'm going to hit clear. I'm going to hit enter. And I'm going to go back to my main screen by hitting second mode. Okay, so the first thing I'm about to do we did before, I'm going to go ahead and hit second stat. And I'm going to go to the right, and I'm going to hit 5 for sequence. And I'm going to type in what this particular sequence was, and that was 2 and x plus 1. Notice I'm not using n. When I'm using my calc, I'm going to push that x button. Put a comma. I'm going to tell my calculator the variable is x, and I'm going to tell my calculator that I want it to be a sequence that goes from 1 to 4. I'm going to close my parenthesis. Now, instead of hitting enter, I'm going to hit the stow button for storage right above the on key. and I'm going to hit second one for list 1. And now I'm going to hit enter, and you'll see the sequence, but if I hit stat and edit, I go back, and sure enough, now in list 1 my sequence is sitting there. So I'm going to come back to my main screen, and I'm going to do something we haven't done, and I'm going to hit the same second stat, and you can follow my keystrokes on the history screen over there. And I'm going to arrow to the left one, and this time I'm going to hit number 5 for sum, and I say, hey Calc, do me a favor, will you, and add up the numbers I have in list 1. And I hit enter, and our same 24 comes back. Now you can see how we didn't really need that in this case, but if I had said, hey, sum the first 253 terms, then you might consider your calculator helpful here. Okay, so let's go back and do another example. More real world, I guess I would say. So, example 2, pretend it's New Year's Day, and you decide you're going to start walking. New Year's resolution. You're going to walk 20 minutes. 20-minute walk. First day. And then you decide you're going to add 5 minutes every day. And this is going to be for a total 2 weeks. A question you may be asked would be something like, how many total minutes in those 2 weeks? Now, without me talking to you about series or sequences, I bet you could figure this out, but I'm here to try to apply this whole concept, especially sigma notation. So I say this really is a sum, and if it was me doing the problem, I often find that if I get my little counter going over here, sometimes it makes me feel like I'm in the game. And I really need to think about how many terms am I adding up. And so if this is going to be for a total of 2 weeks, and I know every day I'm going to have something's going to be changing, I'm going to go from 1 to 14. So now the only thing I'm missing is an equation, and then I could actually put it in my calc and get my number. So where do I get the equation? I'm going to come over here and write down an equation that we have seen before, hopefully. And I want to remind you, you don't necessarily have to memorize this if you understand it. And basically, this a sub n just represents whatever number is sitting at a particular term in the sequence. So if I want the 5th term, I would write a sub 5. And really what it is you just take your first term, and to that first term you add the common difference. Now this is for an arithmetic sequence, so I have to be continuously adding the same thing, which is what's happening up here, because I'm going to add 5 every day. And I'm going to multiply that by the number of steps it takes me to get to the term I care about, which is always going to be 1 less than the number of the term from what we talked about a couple sections back. So if I can just figure out an equation to get to any term in the sequence, then I can put that into my machine, and my machine will find me all the terms. So in this situation, my first term is 20. So I'm going to put a 20 down. Now, in order for this to work in my machine, I need that n to be sitting there in my equation, so I'm not going to put anything in for n, and I'm going to put my common difference in, which in this case is 5, so times 5. Now, I'm going to go ahead and I'm going to maybe put the 5 out front here, because I'm going to clean this thing up by doing a little distributing. So I get 20 plus 5n minus 5. 5n, and then I have 20 minus 5, which would be plus 15. So if I come back over here and I write 5n plus 15, I have one minor problem, and that is, without putting parentheses around the 5n plus 15, this really means a summation machine that just does the 5n part, and then the sum of that, add 15. So I don't want that, because I need this whole thing to be working in the machine. And a thing you could do is try it. You could say, well, if I put a 1 in, 5 times 1 is 1, 5 plus 15, 20. Oh, that's day 1. Then you could put a 2 in. 5 times 2 is 10. 10 plus 15, 25. Oh, that makes sense. That's day 2. I've got 20 plus I've added 5. So it doesn't hurt to just quick check to make sure it works. And then, rather than having to go through all this arithmetic, I'm going to come back over here again to my calculator. I'll go ahead and clear this. I'll clear my history so you can see that. I'm going to hit my stat button. I'm going to hit edit, and I'm going to go ahead and clear my list. Now remember, you want to hit clear rather than delete. And I'm going to do the exact same process. I'm going to hit second, stat, I'm going to go here to ops. I'm going to hit 5 for sequence. And I'm going to type in this particular sequence, which is 5x plus 15, comma, x, comma, start at 1, comma, end at 14, close my parenthesis, but this time I want to store it, so I hit STO for store into list 1, and I'm going to hit enter. Now I want to actually find the sum of it, and so I'm going to go ahead, I'm going to hit second stat, I'm going to go to the left to get to the math menu, I'm going to hit 5 for sum, and I'm going to hit second 1 for list 1, close my parenthesis and hit enter, and there you have it. That would be 735 minutes of walking. So I'll come back over here and I'll write that down. Now, if someone asked me how to answer in hours, I would divide by 60. So you always got to be careful with your units, but in this case, we'll call it good, 735 minutes. Okay, a couple other vocabulary things that we've seen before. Similar to sequences, we saw a finite sequence. We can also see a finite series. Similar to sequences, we saw infinite sequences, and we can also see infinite series. So as an example, maybe we have a summation where it says I equals 1 to 50 to I. And this I in this case is not an imaginary number, it just so happens that I is being used as the counter. If instead this was infinite, it would be something like this. I equals 1 to infinity. That's where the infinite comes in to I. And we'll work with the infinite series a little more later in this chapter. Okay, so let's do one more example. And this is the problem. Write the sum of the first 25 odd integers in sigma notation. Okay, so this is where vocabulary comes into play, because if it's June and you haven't thought about this in a while and you're asked to write something in sigma notation, somehow your brain needs to remember that guy. Now, as I said before, for me, a lot of times if I can just get the counter going, it kind of makes me feel like I'm in the problem. So I know in this case I'm adding 25 things. So I'm going to go ahead and realize that this summation machine is going to have to spit out 25 numbers. Now, the harder part is writing the equation. And as long as it's arithmetic, I can use this. And hopefully get you to agree with me that in this case it is. Because if you just take a minute and think about odd integers, 1, 3, 5, 7, 9. Actually, let me make this more specific and say positive odd integers. Dot, dot, dot. I think you would agree, hopefully, that we continuously add 2, so we have a common difference, so it is arithmetic. So similar to the last problem then, the first term is 1 plus n minus 1 times the common difference, which for odd integers is 2. Maybe I'll sneak this out front here so I can distribute. 1 plus 2 times n is 2n. 2 times the negative 1 is a negative 2. So I have 2n, and then I have a 1 minus a 2 minus 1. So I'm going to come over here and drop this on down, and hopefully that will spit out the first 25 integers. So I might just try it. So I start at 1. 2 times 1 is 2. 2 minus 1 is 1. Okay, so far. Go up to 2. 2 times 2 is 4. 4 minus 1, 3. Yep, 3. 2 times 3 is 6. 6 minus 1, 5. It appears to be working. So there you have it.